Namaste, and welcome to our continuing series on homeopathy with our beloved Dr. Pachagavkar. Today, Dr. Pachagavkar will take up the respiratory system.
Respiratory system is again connected with the circulatory system in many ways. Through respiration, our body maintains its oxygen level in the blood. At the same time, there is even excretion through respiratory system. In this system, we inhale the atmospheric air for supply of oxygen, and at the same time we exhale the air which contains things which are not required, that is carbon dioxide and all. And it's a very complex and it's a vital organ in our body. In humans we have two lungs, left and right. Right side has three lobes and left has two lobes, segments rather. And it's a network of alveoli, a small alveolar tissues. These are parenchymatous tissues where each alveoli is surrounded by capillary network. Not only that, this capillary network and these alveoli, that so much they are in closely knitting there, that the capillary wall and the alveolar wall membrane, they are connected. They are almost one membrane, they share the membrane, and through that there is diffusion of air. So blood doesn't get free from vessels, it is flowing through vessels. Through arteries it flows in, and through capillaries again the exchange takes place, where the oxygen from the air is absorbed, or we call it by diffusion, it gets bound with our hemoglobin in blood, and through blood it is transported to heart for transport in the remaining body. At the same time, carbon dioxide is excreted through exhalation, it is collected. It's a whole tree. The passage starts from nose and mouth. From both sides it opens in throat, that pharynx, and then it goes to trachea. It's a main tube which carries air, and trachea bifurcates through bronchial tree, bronchi on both sides, and these bronchi, they again divide into small bronchioles, supplying or connecting each alveolus to this network. Imagine our one human body has more than 600 million alveoli. Such a network we have. And the whole blood, every time blood flows through capillaries, and there with the diffusion phenomena the exchange takes place. The oxygen is absorbed or taken up in blood, and carbon dioxide is given away through alveoli, so that again through exhalation it goes off. So every time we inhale and exhale, in normal course around 500 ml of air is inhaled in normal course, and there is residual air in the alveoli, and that also is there, and then we exhale almost equal, like we inhale and exhale almost equal, but the vital capacity is almost 5 liters. So someone who is exerting and where ventilation is required more, you respire deeply, your inhalation can be even up to 2 liters capacity. And then when you create vacuum, the inhalation takes place. It's our diaphragm, which is again a muscle, which is in the basement of our mediastinal or chest, we can call it. Actually diaphragm is something which divides abdomen and chest. And the diaphragm actually movement facilitates breathing. It provides energy or dynamism to our breathing. So when the diaphragm expands or constricts, there is air entry, there is vacuum created in the chest, in the lungs, and then inhalation takes place. And when the diaphragm, it comes back to its normal place, exhalation occurs, it provides pressure. So inhalation and exhalation is mainly done by our diaphragm. That's what we call abdominal breathing or diaphragmatic breathing, which is better. But even chest has some sort of a spring like action, spongy, there is possibility of expansion. So our chest also expands.
As a singer, I know this all very well.
Yes. And see, it's a very another function of this respiration. It is not only providing oxygen and carbon dioxide, it provides the momentum for our speech, the voice.
Yes.
The voice box
yes.
is a mechanical thing, but the main, the monitoring is done by our respiration. We exhale air, and that too while exhaling we have capability of creating sound, and not only creating sound, but well monitored precision phonations come out. Especially there is, and see, the funniest part is we have a network of sinuses. We have almost 4 pairs of sinuses in our respiratory passage, nasal passage, like maxillary sinus, frontal sinus, sphenoid sinus, ethmoid sinus. So 4 pairs we have only within this area. And these sinuses, they are almost like cavities, bony cavities, space, bony space. And this space facilitates all these things. Like it can give a impetus to the sound. So in that piriform fossa, what it's a small area in the near the pharynx, just below the pharynx, that helps us in managing the amplitude and frequency of the sound. So along with exhalation of unwanted gases or materials, it can even facilitate this phonetic thing phenomena also. What we are talking, with what tone we are talking, so everything is governed by our respiratory passage. And not only that, these sinuses, this URI, what we call respiratory tract till throat, there is mucus secretion, and these mucus secretions facilitate that whatever air we inhale, that acquires humidity, what is required in our system. So it is that humidity is provided or monitored by our system through these sinuses. And not only that, there are ciliary membranes which arrest the dust particles or harmful bacteria or antigen entering our deep lung tissue. So in the nose only there is filter. There are hair, which arrest the dust, gross dust, then fine dust. And not only that, if it is arrested in the mucous membrane through ciliary action, the dust particles and all these unwanted material, bacterial material, everything is carried to outside in the throat to the lymphoid tissue. In pharynx we have adenoids, and again in throat we have tonsils. So there it is carried and it is arrested and thrown out. And we don't realize, on an average 2 liters of fluid is secreted every day in ENT passage. And these sinuses and all, the fluid is under continuous circulation and it is recycled. So it is secreted and absorbed, so it does its job. So the sinuses, they are so much helpful in governing our tone, the phonetic output, and speech, singing, all this. But at the same time, they are helpful in arresting the organisms, at the same time providing good humidity to the air what enters our lungs. And not only this, bronchial tree also is so efficient that it has wonderful elasticity. It can expand. Imagine it can expand to the extent that it can contain 5 liters of air in that, and then it can just throw it off in the form of exhalation. So this is efficiently done by the bronchial tree, the alveolar network, as well as the trachea. And this junction, throat is a junction box for our food passage and respiratory passage, and that epiglottis is a small apparatus which governs it. So when you are eating, the tracheal passage is shut, sealed temporarily till you swallow, and once swallowing is over, then you again start breathing. And there's a small apparatus called epiglottis, and that governs it. So such a wonderful network of tissues and organs in the respiratory system, and very efficiently for whole life the person is breathing. These are the organs where they have to work continuously from birth to death, and that too in close collaboration with heart, because heart is pumping blood to lungs for oxygenation, and once it is oxygenated again, it is taken back to heart, and then it is circulated in the body, and this nexus is continuously going on. At the same time, the voice is monitored. By just listening to this voice, one can make out that this and this person is speaking. So it's a wonderful system where everything works in close synchronization. Not only that, through our eyes, like what tears we get, because our eyes will also need to be maintained wet, because constantly the lacrimal fluid is secreted in eyes for keeping it healthy, and that fluid is circulated through again nose. So the lacrimal duct opens in nose. So we find that sometimes if nostrils are blocked, the lacrimal duct gets blocked, and there is lacrimation or abnormal discharge from the inner canthus of the eyes. And more than this, the olfactory sensors, they are again in our respiratory tract, in nose. So we can even judge the smell of the thing through this respiratory system. So it has these many functions.
You had mentioned, I don't know if we covered bronchitis before.
Not it. Yeah, this bronchitis is something where there is inflammation of a bronchial tree. And this bronchitis is actually a sort of a passage from trachea to lungs. But this bronchus is not one. This bronchi, it's a network. Like it divides into small branches, and small bronchioles are there. So sometimes there occurs inflammation in this bronchial tree, and that is what bronchitis it is called as, because there is inflammation, there would be some debris or discharge of mucus, and that mucus discharge has to be excreted, and and there is again a network of ciliary epithelial cells lining the bronchial tree. And sometimes what happens, there is one more condition called as bronchiectasis. In bronchiectasis, what happens, the bronchial tree, the bronchial wall loses its elasticity. So it should expand and constrict, along with the air entry and air expulsion. That fails. Sometimes if it is dilated, it fails to come back to original place because of loss of elasticity in it, and there is a degenerative change in that. That is called as bronchiectasis. So bronchitis can be chronic or acute, and then bronchiectasis. So these are conditions which people confront very frequently.
Ah, very, very interesting. Thank you, sir. Namaste. Namaste, all. We'll see you next week.